This is lesson 10-2, simplifying radicals. So first we need to discuss what a radical is. It's any term that's contained inside of a root sign. And the root sign example is right there to the right. The radicand refers to a number that is underneath the radical. And if a number, which is the index, exists in the valley of the radical sign, that's the root you want to take. So underneath this would be the radicand. And right here, if there was one, would be the index. Now you can see that there's none for that particular sign. If there isn't one, we assume that the index is 2, which means you're taking the square root. Here's some examples. Now the first one is the cubed root. You can see the 3 as the index. And so the cubed root of 27, you can put that directly in a calculator and you get 3. The square root of 64 is 8. So breaking down numerical radicals, the first thing you want to do is find all of your factors of the radicand. Again, you could simply do that in the calculator if you're having trouble finding factors. Next, pick the biggest possible perfect square that's a factor of the radicand. Next, break it up into 2 square roots. Use the factors that include your biggest possible perfect square. So in other words, you're using the pair of factors that includes that biggest perfect square. Next, you want to simplify from there. Here's some examples. I'll do radical 40, and then you can do 3 radical 72 on your own. Radical 40, we first find factors of 40. So 1 and 40, 2 and 20, 4 and 10, and 5 and 8. The perfect square factors are 1 and 4. 4 is the biggest one, so I want to select 4 and 10. I then break it up into those 2 factors and having a radical sign with each. Now, radical 4 can be simplified in your calculator if you do it. Radical 4 is equal to 2. Radical 10 cannot be simplified. So your final answer for radical 40 is 2 radical 10. Pause the video at this point to give yourself a chance to try 3 radical 72. So in simplifying radical 72, we certainly don't want to touch the 3. We leave the 3 alone because it's already on the outside. Factors of 72 would be 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Lots of factors to choose from. The biggest perfect square factor of 72 is 36. So I'm going to break 72 down into radical 2 and radical 36. Radical 36 can be simplified to 6. Now notice that 6 comes on the outside and we lose the radical sign. We want to take this and join it with the 3. We join it by multiplication. 6 times 3 is 18. And then we have radical 2 left over. So your final answer for 3 radical 72 is 18 radical 2. Let's talk about breaking down radicals that have variables involved. So if necessary, if you have more than one variable, you want to separate all of the variables into their own radicals. Next, break down the variable. If the exponent is even, simply cut it in half and pull it out of the radical, because any even exponent is a perfect square. If the exponent is odd, break it down into 2 radicals, one with the variable only, and one with the variable having 1 less than the original exponent. Next, simplify. And make sure you multiply together anything on the outside of the radicals, just like we talked about in the last examples. Here's a couple of examples for you. I'll do radical x to the fifth, and then pause the video to do 3 radical x to the fourth, y to the third. 5 is an odd number, so I want to break it down into the variable itself underneath a radical, and then 1 less than the original. The original was 5, so I break it down into x and x to the fourth. Now we have an even power underneath a radical. We simply cut it in half and pull it outside the radical, x squared. This, because it's on the outside now, goes in front. So my final answer for this one is x squared radical x. Pause the video at this point to try the other example. So we'll leave the 3 alone, and first we're going to separate the x and the y. X to the fourth, as we just did previously to the left, is simply just x squared. So that can come out because it's an even power. Y to the third, because it's odd, needs to be broken up into y squared and radical y. Radical y squared simplifies to simply just y, or y to the first. Radical y stays by itself. I take all of the outside parts and put them together. So my final answer is 3 x squared y, and then radical y. Let's talk about the multiplication and division properties of radicals. When products or quotients exist inside of radicals, it is possible to pull factors apart. Here's an example. When you have radical 32 n to the third, it's simple enough just to pull the parts apart and have radical 32 and radical n to the third. For division, if I have a fraction underneath a radical, I can simply just take the numerator and denominator and put a radical sign over each, and then simplify. Here's how we break down radicals when they have numbers and variables. I'll do an example to the right as I go through the steps on the left. Step 1 is to separate the variables and coefficients if needed. I'm going to do that here by separating this into radical 72 and radical x to the third. Next, simplify the numerical radical first. Earlier, we simplified radical 72 into radical 2 and radical 36. Radical 36 comes out because it's a perfect square, and it's simply just 6. Next, simplify the variable radical or radicals if you have multiples. X to the third can be simplified into radical x squared and radical x. Radical x squared is an even power, so it can come out with cutting the exponent in half, so it's simply just x. Next, combine the 2 types of things that you see. Put anything on the outside belonging on the outside. Multiply your numbers and variables together. So as you can see, 6 and x belong on the outside, so I'll put them on the outside. Leave everything else on the inside. Multiply the numbers and the variables together. We have a radical 2 and a radical x. They will stay on the inside together to form radical 2x. And that is your final answer simplification for radical 72 x to the third. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. So for the left side, I'm going to leave 3 alone and break up radical 150 and radical b to the 8th. Radical 150 can simplify into radical 25 and radical 6. Radical 25 is 5. Radical b to the 8th will cut the power in half since 8 is an even number, and we're left with b to the fourth. Round up everything that's on the outside, which includes this original 3 on the outside. 3 times 5 is 15, and we have the b to the fourth. The only thing we have underneath the radical is the radical 6, and that moves down here. That is your final answer. For the right side, use the division property of the radicals and break it up. Now we'll attack each of these individually. So I have radical 3x to the third, and I simplify that to radical 3 and radical x to the third. There are no perfect square factors of 3, so there's no simplifying radical 3. Radical x to the third can be simplified into radical x squared and radical x. Radical x squared becomes x. So on the top, I'm left with x radical 3x. For the bottom, we have radical 64x squared. That can be broken into radical 64 and radical x squared. Now, radical 64 is a perfect square, so that becomes 8. Radical x squared is also a perfect square. That becomes x. So on the bottom of my fraction, I have 8x. So let's rewrite the fraction as x radical 3x over 8x. Now to simplify this to the fullest extent, because we have x on top and bottom, it is possible to take these out. And so my final answer would be radical 3x over 8. Lastly, let's talk about rationalizing the denominator. By rule, a fractional expression is not simplified if the denominator has a radical. To rid a denominator of the radical term is called rationalizing the denominator. To rationalize, simply just multiply the top and the bottom of your fraction by the denominator. Here's an example. 1 over radical 5. To rationalize it, I want to multiply the top and the bottom by radical 5. Multiplying that gives me radical 5 over radical 25. But radical 25 can be simplified to 5. So my final answer is radical 5 over 5. Now those two 5's cannot be canceled because of the radical sign on top. That is your final answer. Here's a couple more examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. For the left side, I want to multiply by radical 11 over radical 11 on both sides. That gives me 3 radical 11 over radical 121. Simplifying radical 121 would be 11. So my final answer is 3 radical 11 over 11. On the right, we're going to break it up. So we have radical 12x to the third on top and radical 8x squared on the bottom. We can simplify this by multiplying by radical 8x squared over radical 8x squared. This now gives me, on top, radical 96x to the fifth over radical 64x to the fourth. Now we need to simplify both of those radicals. Let's do the top first. Radical 96x to the fifth. We break it up into the number and the variable first. Radical 96 can be simplified into radical 6 and radical 16. Radical 16 is 4. And then radical x to the fifth is simplified into radical x to the fourth and radical x. Radical x to the fourth becomes x squared. So putting them together, I end up with 4x squared radical 6x. On the bottom, radical 64x to the fourth is much simpler. Break it up into radical 64 and radical x to the fourth. The 64 becomes 8. The x to the fourth becomes x squared. So my final answer here becomes 4x squared radical 6x over 8x squared. This could also be simplified because we could take out the x squareds, one on top and one on bottom. And if you see it, you can reduce 4 and 8 to 1 over 2. So your final answer here is 6x, radical 6x over 2. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.